Okay, so let's take a look at how to locate the epicenter of an earthquake using the triangulation method. All right, so here is a map of the world, and we're going to zoom in on a particular region. We'll look at North America, and let's imagine that there was an earthquake somewhere in North America. Well, the question arises, where was the epicenter of that earthquake? Now, we may be able to get a general idea of where the epicenter was based on looking at the severity of damage, eyewitness reports, etc. But if you want to pinpoint the actual location of the epicenter, you have to do some calculating. And so let's look at how we're going to do that. First off, in order to pinpoint the epicenter, you need a minimum of 3 seismic stations. So let's pop a few of these seismic stations on the map. Let's say we have one here in California, one up here in Canada, and one down south here, labeled 1, 2, and 3. Now, these are locations where we have seismometers actively monitoring the shaking in the Earth's crust. Of course, we have seismic stations all over the world. In order to use this triangulation method, we need at least 3 of these, or data from 3 of them. So, step 1 is going to be to take the data, the seismograms from each of these stations, and determine each of their epicenter distances. That is to say, I want to know how far point 1 is from the earthquake, how far point 2 is from the earthquake, and how far point 3 is from the earthquake. And this is fairly easily accomplished. You would simply find out the difference in arrival times for the P waves and S waves, and then use a travel time graph to calculate the distances. So let's say you have done that, and you have established that seismic station 1 is approximately 700 kilometers from the earthquake. So something like this. But the problem is, we don't know if it's 700 kilometers in this direction, in this direction, in this direction. We don't know. It could be 700 kilometers in any direction. So what we can do is draw a circle around point 1 with a radius of 700 kilometers. And now we know that the epicenter is somewhere on that circle, somewhere on that line. But again, that's not good enough because we want to pinpoint the location. So let's turn our attention to location 2 and say we did our math and we found that location 2 is 3,000 kilometers from the epicenter. Now again, it could be 3,000 kilometers in any direction. So we will draw a circle around point 2 with a radius of 3,000 kilometers. Now notice something. If you did this properly, your circles should intersect, most likely in 2 places. And what that means is that the earthquake had to happen either here at this intersection or here at this intersection. But again, that's not good enough because we want to know exactly where the epicenter was, which leads us to station 3. We take our seismogram, we do our math, and we determine that station 3 is approximately 3,500 kilometers from the epicenter. So, again, it could be in any direction, so we take a drawing compass and we draw our circle with radius 3,500 kilometers. Now, if this works out properly, all 3 circles should intersect in one single point, and that point is your epicenter, shown by the pink star. This is what we call the triangulation method for locating the earthquake epicenter.